is Hadoop. So we'll start main components of Hadoop and why this Hadoop is required to handle large amount of data. Why not other programming or processing tool we use? Okay, so first we'll see the why part, objective. Now, when I say Hadoop, so it has got a three different version, guys. 1.x, 2.x, and 3.x. Three different generations are there. We will be working with the 2.x 2.9.0 because 1.x is deprecated, nobody uses it. 3.x is currently in production, so it's not yet stable. Though if you want to see how it looks, you can download it from Google. It is available in their index link. Okay, so just for testing purpose, you can check it. But production stability is with 2.x, and we got this second generation after 2012. So definitely, industry claim that Hadoop started working since 2008, but in 2008 this was a very basic version. We had many issues there in 1.x. It was having a single point of value, a couple of node only available, only few block you can process. Okay, so we'll see this limitation when we compare between 1.x and 2.x. And Hadoop is designed by a community called Apache. Hadoop is designed by a community called Apache. So it's all managed by Apache. And the best part, it is all open source, right? Apache is open source, and we can download Hadoop framework from Apache. We can download Java framework because program, Hadoop is not a tool or a language or a programming model or processing concept. Hadoop, if you ask me in simple words, I'll say it's one kind of API or it's a framework. And this framework, it is designed in native C, native C, and core Java language. This framework of Apache Hadoop is designed with native C and core Java language. Does that mean if I do not know this language, if I do not know this language and this language, can I work with Hadoop? So the similar question I had also, and when I started working as a Hadoop engineer. So it supports all major platform, guys. There's no compulsion that only I can design my program using these two languages. It supports all different major platform or major languages, I would say. So you can write your logic, your business logic, your class with any of the language. You can use Python, you can use Scala. So we know, right? This too is a most popular language currently in 2020, and they are popular language since 2017. So it's been 3 years for Python and Scala. And the best part, if you learn one language, let's say, so we'll be learning this Scala part in our session while writing codes in Spark and in other processing side. So when if you know Scala, you know already Python 80% because syntax of Python and Scala is very similar, like function creation. Only the internal compilation status is different because this is a pure object oriented programming language. Scala is known as a 100% object oriented programming. Java is not a 100% object oriented programming language, right? Python is a functional programming language, and likewise we have Ruby, we have Groovy, we have we have C, we have C++. Okay, so I can use, there are many other Swift and play other languages also. I can use any of these languages to write my logic in this platform, in Hadoop platform. And Hadoop is driven by master and worker methodology. Often time if you're reading any textbook, So this worker is also referred as slave. Hadoop is driven by master and worker methodology. We'll see what is a master and what is a worker. Every single point we'll see one by one. Now, we are claiming that big data is a problem. We're claiming from beginning that increasing of data or exponential increase of data is getting a problem for industry every day, and that's what is having a name as big data. In fourth generation of data, we call them a fast data. Okay, so big data problem statement came since 2005, and Hadoop journey started right next that year. So they said we will work with a multiple node, and we will try to achieve the parallel processing concept. So in uh, demo part of big data, we already know that whatever category, uh, structured, unstructured, semi-structured, combining this whole set of data we are calling as a big data. Massive volume. Okay, there's no fixed number that data which are beyond terabyte only I'll call as a big data, or data which are beyond petabyte only I'll call as a big data. So currently I'll call this big data as a problem statement. I'll refer this big data as a problem statement, and Hadoop as a solution. Hadoop as a solution. Okay, so we'll see how this thing can be solved, because if you again go and see the point of big data, what was the main pain point in big data? So this too was the problem. First problem, we were unable to store this data. We were unable to store this data in rdbms because rdbms can only handle structured types of data. rdbms cannot handle semi structured and unstructured data, right? Then if I'm unable to store this data, how will I process it? The processing part can never be start. If you cannot store any data, you cannot process them. Very simple. Nothing can be processed on the fly. If you don't know server location, how can you read it? How will you call your connection URL? Right? So storage activity is very important. Once I know this part, then I'll talk about processing. Now Hadoop says I have a solution for both of this problem. Hadoop says I have a solution for both this problem, storage and processing. And those solutions are known as a component of Hadoop. So when Hadoop strategy was defined, there is a huge contribution by Google. So Google had designed one paper called GFS, Google File System. Okay, if you want to read about GFS, you can find easily this in website. This is available. It's a white project. Uh, it's a paper. Okay, research paper, and shown by Larry Page and Sajabin in the Stanford University couple of years ago. And using this concept or inspired by this paper, they got a solution of storage and processing. So whenever we see Hadoop, there are all large, big internet companies. Their contribution is very high. Talk about Facebook, talk about Yahoo, Amazon, any company, Twitter, LinkedIn. They have their own individual tool to handle this big data problem statement. Okay, it's not designed by some company or just one firm. This is a contribution of many industry. So next part, how we are storing this. How we are storing this. Hadoop has got two component. Hadoop has two components. First component is a first component is a storage, and to store this data, we are using HDFS. Hadoop Distributed File System. The abbreviation of this HDFS is a Hadoop Distributed File System. I'll tell you what is a Hadoop distributed file system. We'll visit this part after getting this processing part. Processing. And for processing, we are using technique of MapReduce. Okay. MapReduce is initially designed by Google only. And today you work with a concept. Let me take one example for you here. So let's go to Google first and search for some key, search for some information. So if we want to search anything, that's what we do. We go to Google and ask anything. So any other than COVID-19, any recent topic in the world. So let's search for Spark version, a Spark latest version. I'll just give this keyword. Okay, Spark latest version. Now, when I give this Spark latest version as a key, you'll observe two things. First, what I have written, this is what, and this is what. Spark latest version, this this thing is a key. This thing is a key. And you're getting output as 90 million. This is nothing but a value. So when you're searching or looking for some data from a Google has got a 17 data center and 9 lakh server. So how they're reading this information? From where they're reading this information? From one particular data center or from one server? That's again we'll see how MapReduce processing comes. But I'm just giving you one teaser that how thing can work in a MapReduce. You guys work with a key value concept, but we don't know that whether it is a key or value. Now, if you see here, the time total taken by Google is 0.45 seconds. The time is very less. Why they're able to balance the load and how this time is reducing? This all part will come in the processing side of MapReduce. So just for now, you can see whatever you are searching, that is your key, and what output you are getting, that's your value. Now, if you start looking out this key in your this number of link, right? Now, if you ask me how this link is coming, there is no relate. This is not related to MapReduce. This is related to advertisements or digital marketing. That how things are coming at first place, second place, third place. But this keyword which I have written, if it is matching, you can see these are highlighted. These are bold words. So releases maybe by default, but wherever you find a Spark latest version, you'll often see that this is with uh, your key is getting highlighted here. Okay. Hadoop distributed file system. First, we'll visit this part. But first question: What is the difference? What is the difference between what is the difference between RDBMS and HDFS? Because without knowing this reason, we cannot directly jump to Hadoop part. RDBMS, at one side I'll write HDFS. Let's see point wise. First point, first point that RDBMS does not deal with the file. When I say RDBMS, I mean Oracle, MySQL, Teradata, Ab initio. uh, MicroStrategy, Net is a bunch of RDMS DB2 we have. Okay, and we have seen in last two session how we can do, we can create table, we can insert record, we can define primary key using RDBMS. So in RDBMS, strictly it is a concept of file system. Okay, and in HDFS, sorry, I just replaced it. In RDBMS, it's a table concept. First, you are creating a table, then you are inserting a record, right? So if without creating a table, I cannot insert any information. So first I will do DDL, then I will do DML, then I will do DRL. And in HDFS, we are not having any file system. What is the abbreviation of HDFS? Here you have a file, Hadoop distributed file system. So they do not deal with the table. They work with the concept of file system. Second point, RDBMS is inspired by ACID properties. ACID uh, stand for atomicity, consistency, isolation, and durability. So these are the properties or point for RDBMS. When RDBMS defined, they given this many feature to RDBMS, and hence your RDBMS works with the concept of write multiple, read multiple. This is a shorthand. WMRM stand WMRM stand for write multiple, read multiple, which means I can anytime write to my table and I can anytime read from my table. So writing and reading, there is no limitation that only I can write once or I can read once. I can do both the activity at any time and from many number of client. Here, this is the limitation. This is exactly opposite. It is saying that it works with the write once and read multiple concept. I'll tell you this WORM point, why Google file system or other strategy have defined the write once strategy, because uh, because writing different types of data in a single block would be difficult. In RDBMS, you know that you're only handling structured data. You're only handling structured data, so you know the type of data. But here you're not handling structured data. Here you are handling structured, unstructured, semi-structured, right? So you cannot write in a file, in a single file. You're not supposed to write a structured, some structured information and some semi-structured information. So that is the reason architecture of Hadoop, when it was defined, so they said we will only allow any file to return once. We cannot allow twice or thrice for the same file. So they are only handling structured data, and this is for structure, semi-structure, and unstructured. Fourth point, RDMS processing is a sequential. RDBMS processing is a sequential. HDFS is a concept of parallelization. They try to process any data using parallel processing concept. So what is a parallel processing concept and what is a sequential? Let's see here. Suppose I have one server as my centralized server. This architecture I'm defining you about RDBMS. Way back, this architecture was defined, and there was no gap or no class to redefine it again, because we cannot convert any sequence to processing. So how that sequential concept of RDBMS is working here? We have one centralized server from where we run a query. Okay, this is your server from where you run a query, and then your data is distributed in different locations. Let's say this is DB first. You have some data available here, you have some data distributed here. I'll name it as DB1. Then you have some data distributed here. and this is in USA. Let's say this is in USA, this is in Africa region, and this is somewhere in DB3, this is somewhere in Asia Pacific. A question, when I'm running a query here, because my query is going to centralized server, when I'm running a query and my query is saying this, select select uh, select a star from table, whatever is your table name, where where salary is, let's say this record is related to population. So we have stored information about population of US, Africa, and Asia Pacific to one database server. And from this database, we are saying this task is actually coming from a business. That business is saying. So first, let me define the task. Then we'll go to solution. My task is to identify how many people income or salary is less than $1,000. Out of all this location, I'm not defining you have to get this data from one specific reason. I'm saying from the whole database, how many people earn strictly less than $1,000. So this query I will run here. Select star from table name, where salary, whatever the column is, if column name itself is income, then I'll write where income is less than $1,000. So if this is written in a float or a double data type, I will give 1000.00. This is my query. Once I run this query from here, you guys know what will happen. It will not send this query all together. Let me change the color. So it's not sending any query here and here and here at one shot. What it is doing, it is sending one request to DB1. It is sending one request to DB1. This is a request that, do we have any result which are matching with this? Do we have any result which is matching with this DB1? It will check, and if data is available, then it will say yes, we have some of the data available. So after making a request from here to here, this is your acknowledgement, and here you are pulling this data. You're pulling this data from here to here. And similarly, again, second request, you will make it for DB2. This is your request based on the query which you are running this query. Again, DB2 will respond you back that yes, we have this many record available. So let's say in USA, we have total 1 million record. In Africa, we have 50K data point. And in DB3, which is SA specific, we have just 100K data point. So when I say data point, I mean row, number of rows, okay? Because RDBMS is orientation of a row database activity. It does not follow the column concept. It's a row oriented database. This particular thing is a row oriented database. Do we have any column oriented database? So yes, in Hadoop ecosystem, if you guys know NoSQL concept, HBase, MongoDB, Cassandra, we'll see that one of them in our whole module. So NoSQL works with the concept of column-oriented database. This is a row-oriented database. It's not the right time to discuss about the column-oriented database. When we visit HBase or Cassandra, then we'll see how that NoSQL thing works. Again, this will pull up. So after sending a request, again this will pull data. So out of 1 million, 0.33 million result is matching with this query, let's say. Okay, 0.33 million rows are matching with this query. So all this 0.33 million data will be pulled up from here to here. Out of 50k data point, 5k data point are matching with this query. 5k data point will go from here to here. Here in 100k data point, we have just 2k data point matching with this query. Again, this will go from here to here. When you are working one by one from one database to your centralized server, this concept is nothing but a sequential concept. And that is the reason RDBMS query takes a lot of time to process your one query. Even I have experienced some of the query is taking 28 minutes also in the space of RDBMS. Okay, so you imagine that if I'm running this query in a business and this query is getting me output in 30 minutes, do you think it's a right observation? It's a right place to work with this data set? Because when my volume of data is increasing, and why this is happening, because I am processing whole data set in this server only. I am processing this whole data set in a centralized server. I have just one server available. I do not have multiple server. But in Hadoop, we'll see in Hadoop we have a multiple server available. How Hadoop architecture works now. So if this thing is clear, the sequential part, let's go and see architecture of Hadoop. I'll just try to relate with this previous image. So same way I have my master. I'll not say here now centralized server or DB1, DB2. Hadoop is driven by, if you see this point, master and worker methodology. So now it's the time to discuss what is master and what is the worker. Master, slave 1. I'll keep 3 slave 2, slave 3. And I will take one example of IT organization here. Okay, my example is related to IT industry, IT org. So here we'll use some metaphor to understand this concept. We in IT we have project manager and we have developers, right? So we have project managers and we have developers. Now, when client is giving any task, client is not directly talking to developer, right? Client is talking to the head of the project, who is a project manager. Or nowadays we do not have delivery managers or project managers, since we are working with the agile methodology. Here in the place of this, we have got a scrum master. Now, if this client will say, I need to perform 4 tasks, I will have to write a 4 different programming concept. It will pass this high level design or requirement to PM. Then based on this developer expertise, so let's say there are total, under one project manager, there are total 3 developers, D1, D2, D3. Someone is good in programming, someone is good in database, and someone is good in monitoring activities. Okay, looking at their expertise based on this task, what I'll do, I'll give this work to this D1, D2, and D3, and I'll ask it the same time. I'm not writing, remember here, I'm not doing this 4 tasks by myself, because maybe I'm handling, or this project manager is handling 4 to 5 projects. So every task cannot be done by this guy. He is just a mediator. He's just a mediator between client and these people, D1, D2, D3. Project manager given one task to D1 and ask what's your ETA, estimated time of arrival. What, how many days you will take to complete this task. And we know that in software we are using some tool to track all this. And for example, we are using Jira. We're using Jira in agile methodology to track the status. Let's say I give 2 tasks, 3 tasks to you guys, all 3 of you, and I am asking you, or maybe I have created a Jira story, and I have assigned to all of you. Then based on your progress state, you are updating there that I have completed my 20% work, I have completed 40% work, I have completed 70% work, there is a blocker. So likewise, things are tracking, and everybody can check this zero thing. Similar way, PM will ask ETA from this guy also, from this guy also. Based on this, I will get to know what is their bandwidth. So when soon I can assign a new task to this D1, D2, and D3. So after completion of their work, what these guys will do, this will update me that yes, I have completed my task. So my bandwidth is free, and now you can assign me new task. D2 will say the same thing. D3 will say the same thing after few days. Okay. So once PM has collected all the information from this D1, D2, D3, PM will communicate back to client that all 4 tasks which you had asked to do is now done. Please check it and verify this, whether you are looking for the same output or you want some changes. This is how IT organization is working. We all know that. Let's compile the same thing in master and slave analogy. Okay. In master, this is a point who is mediating now. So I'm replacing this master with the project manager, and I'm replacing this slave or worker with the developers. Okay. And I have got my data stored in this machine. Let's say in slave 1, I have total 3 file available. I have because in HDFS we are working with a file concept, it's not a table concept. I have 1 file available, and I have 5 file available. When I'm running a query, so this is my data. There I have stored my data. Okay. In all of this machine, I have stored my data. I have stored my data. When I submit a query to all this machine, when I submit a query, because my query point is this, when I'm running a query from client machine. Look, when I'm going to search something on Google, who am I? When I'm going to search something on google.com, I'm a client. I'm a client, and I am going to search something on the server. And this server is coming from www.google.com. This is one DNS. And this DNS is mapped with some of the IP address, because I can call you by name. I can call you by name, but how do I call any server? So if you want to know that part, how can we call any server? For that we have to know concept of network strategy. So let me open a terminal, and in terminal you'll see how any communication happen. Because if I ask you, do you guys remember what is the IP address of Google? Anyone? What is the IP address of Facebook? Or what is the IP address of LinkedIn? Nobody remember, even I don't remember. So what we do, we ping this DNS, google.com. If I type this, I'll get the IP address of it. If I ping my second address, let's say facebook.com or youtube.com or any website. Okay, any website whichever is public, you can ping it and you can get to know that what is their IP address, what is this IP address. So your communication is happening through this IP address only to this website. When you go to this website from your machine, so what is your machine IP? So your machine, you can check it using my public IP. If you type in Google here, what is your public IP? This is your public IP. Your communication is going from this IP to 172.217.166. Let me write it here. 172 dot 217 166 and 164. This is how internally communication is built. So from this IP to this IP. Now we'll see this IP is hosted. This IP is hosted in which region? What is their reason? And how do you check that? So there's a website called iplocation.net. iplocation.net. Since this is coming from Google, okay, since this is coming from Google, we know that Google is having 17 data center and 9 lakh server. And you know where their main data center is hosted? Out of 17, their main data center is hosted. Their main data center is hosted in US, in CA, in Mountain View. Now when I'm requesting anything or I'm using that IP, I think there's a question I'm just coming is iplocation.net. So if I go to this IP and I'll print this IP address here, 172.217.166.164, and click on this IP lookup. This main thing is hosted. Their main, obviously, uh, Google main data center is somewhere in US, and precisely it's in this location. That's what I have written there previously. But it does not mean, look, I had written earlier the same information, which is this. But it does not mean that every time my request is going to US, because what they do, they check the client location. Currently I'm calling from India, right? My client location is India, and specifically this is in central India, or western part of one region of India. So they try to check, do we have any server near to central India? So Google has their data center in Mumbai. I don't know about Pune, but yeah, they must have in Mumbai. So if I'm calling from Pune, it is going to Mumbai. They must be having data center in some other location in India also. Let's say Chennai, Kochi. But this will see in the point of data locality. When we'll see how data is located, when you copy the data, how data is located and how this request will happen. This point we'll see more detail with data locality. Okay. So why I'm displaying you all this information? To understand the strategy of master and slave in detail. So data is already stored in the slave one. When client is requesting from here, client is not supposed to communicate directly to slave 1, slave 2, slave 3. Client is communicating to master. Whatever query you are submitting for process or to read the data or to write the data, any information, any query you submit from the client in Hadoop, first it goes to master. And then from master, this guy will check, okay, who is having that data available? Who is having that data available? and then it will not pull up the data, unlike RDBMS. Because if you remember in RDBMS picture, you are pulling the data from centralized server to DB1, DB2, and DB3, and your processing is happening only in one centralized server. I'll exactly do opposite of this here. What I will do, I will submit my process itself here. I'll submit my process. Process means if it is related to processing, if it is related to transformation, if it is related to aggregation, that process I will submit here. That process I will submit here. Similar process I'll submit here. So let me call them a P1, P2, and P3. I'm not pulling any data, guys. The key point, the key difference between Hadoop architecture and RDBMS architecture, that you are pulling data from this to this server. Here, you're not pulling any data. Rather, you are sending your process to your slave 1 machine, slave 2 machine, slave 3 machine. All slave 1, slave 2, slave 3 are working in a simultaneously fashion. They are concurrent business. S1, S2, S3, slave 1, slave 2, slave 3 are processing this P1, P2, P3. They are processing this P1, P2, P3 simultaneously. And hence we are calling, they work with the concept of parallelization or parallel processing. Since I'm not pulling any data from here to this machine, so my load of master is not increasing. It does not, it does not matter now how many file or how many query I'm submitting, because my load has been balanced. My load is balanced because I am working individually with all the slaves. Earlier the image was to process only using one machine. So if you understand the difference, the key difference between sequential concept and parallel concept, let's see the question now. Swapnil, if you have any specific query, please write me down. Because out of 1 hour session, if you ask me to keep to 15-20 minute session just for query, this session would take 5 months to 6 months to complete. We have just 1 hour to discuss, right? So if you have any specific question, you can write me down. I'll definitely unmute you, and then we can discuss the point. It's not a problem. I'm not saying that I'll not unmute you or we cannot have an interactive session. Any question is coming, you can ask me in between. Please do that, okay? That's how the session works online. So after knowing this point, key difference between RDBMS and HDFS. Fifth point is uh, they handle distributed. I'll not say, because currently RDBMS is also working with a distributed format, and HDFS is also working with a distributed. So there is no difference in RDBMS with respect to distribution of the file system. Okay, distribution is available in both, but one big difference again, that their maximum data capacity to process is gigabyte, and HDFS, this is for uh, how what is your size of big data. When we go to this volume, when you go to this volume, let me write actually uh, observation since 2006. Since 2006, so uh, 2006 we had world volume. This was all online data. This was 0.6 zettabyte. Okay, and we know what is the value of 1 zettabyte. We know what is the value of 1 zettabyte. This is exactly equal to 10 the power 21 bytes. It's a huge information, right? Because after zettabyte we have one more as a yottabyte. Then in 2012 this data grows up till 4.4 zettabyte. Then by this year 2012, one prediction done by companies, they said what would be the volume after 8 years, and they got to know some number which was 44 zettabyte, 10 times multiple than the previous number. And in 2017 again we did our calculation. So by 2025 this expectation was, or the total volume of data is about to have 167 zettabyte. So easily you can see, whenever you talk about big data world, you easily have zettabytes of data. You don't say that I will have terabyte or gigabyte of information. So we can say that HDFS can handle zettabytes of data very easily. So this is the difference between RDBMS and HDFS. Any question here? Any question in whatever we have seen in the architecture side of Hadoop master worker methodology, the sequential concept of RDBMS, the parallel processing concept of Hadoop? If there's no question, I'll go to the next point. So this is the difference between RDBMS and HDFS. But do we have any other additional features for HDFS? Do we have any other additional feature for HDFS? Additional feature of HDFS. Additional feature of HDFS. First point, we already seen. I can rewrite it because this is a very important point. Write once, read multiple. So I can write any of the file once only. I cannot rewrite again in the same line. Second point, they work with the concept of block size. And in Hadoop 1.x, this block size was less. It was 64 MB. Let me write in a bracket. This was there in Hadoop first generation. Then in current generation of Hadoop, which is 2.x, this is 128 MB. This is 128 MB in second generation of Hadoop. Okay, but yeah, these are customizable, guys. I can increase and decrease the number. It's not fixed. These are the by default. So if you copy any file, let's have a file here. So for example, we have one video. Can you write this video file in RDBMS? Not possible. But in HDFS, we are claiming that HDFS can handle any type of data. It can be structured, it can be a semi-structured, it can be unstructured. Any information, right? So without seeing the type of data, you can say, okay, I will store this data and the size of video is 500 MB. This information I have just given you so that you know what was there in Hadoop 1.x also. You take this as your main block size because we are discussing about 2.x. Okay, we are discussing currently about 2.x. So if I divide this by 128 MB, question is how many block will it create? How many block? So uh, if my file is available in local file system, this is somewhere in Windows, let's say, or this is somewhere in your local file system. It can be in Ubuntu, Fedora, anywhere. It's not in Hadoop distributed file system. Once you run some command to copy the data, how many blocks will it create? It's a simple math. You can do 500 MB divided by 128 MB. So if you divide your total size of data by default block number, you'll get the number of blocks. So we will get some 3 point something block, right? And first block is having 128 MB size. Second block is 128 MB. Third block is 128 MB. If you multiply all this, if you multiply this or if you add this, you'll get 384. When you combine this three, you'll get 384. You can do your calculation at your end. And if you subtract 384 by 500 MB, last block will get 116 MB. How many blocks you're getting? B1, B2, B3, B4. If you add all of this, you'll get 500 MB, right? But these are my fully occupied blocks. These are my fully occupied blocks because my block size was 128 MB, and I have stored 128 MB of data in one block. Similarly, in second block, in third block as well. But how about fourth block? In fourth block, out of 128 MB, I have only stored 116 MB of data. Does that mean I'm losing 12 MB space in my hard disk? Does that mean I am losing 12 MB space in hard disk because my by default block size is 128 MB? If I'm saying I am only able to store this 116 MB data, so the answer is no, because in hard disk you are taking 116 MB space only. This is one logical division. This is one logical division. HDFS is a volatile. Remember, this HDFS is a volatile. If you ask me what is a volatile and non-volatile, what is the difference between volatile and non-volatile? So RAM and RAM and hard disk, HDD. Let's compare between these two different resources. So when we talk about our system resources, we have hard disk, we have CPU, we have RAM, right? Whenever you write any cache data, so you open some website and you start doing some activity. You open some website and you start doing some activity. So this information or whatever you are doing here, it will be stored somewhere in the cache. It will be stored somewhere in the cache. In earlier days, in time of Windows XP, we used to call this concept as cookies, local cookies. So cookies is working locally with your system only. Cache works on the server level. Cache works on the server level. I'll explain this cache concept just in a little while. So what do we mean by cache? So suppose I'm going to this site, or I'm visiting to YouTube, or I'm going to Netflix. I'm visiting couple of sites, LinkedIn, and etc. Okay. So when I go there and I search something, I I process something, I watch something, all this information are stored in a cache. And cache does not go to hard disk, or cache goes to RAM. This will be only there. This will be only there till the time the system is up. Once I close this, some of the cache will be there and some cache will be deleted. Those you can see in your those you can see in your history file. So if you want to see about this cache, you can go here and see your history. This is a history page. If you're using Windows, the option is different. If you get, I think you get option like this. So cache data goes to RAM, but if you want to permanently store this cache, then you will have to convert this cache into file, and then this file stores where? In hard disk. So that's why this RAM, whatever information you're storing in RAM, just for query purpose or reading purpose, or a watching purpose, this is not a permanent storage. RAM is never a permanent storage. Hard disk is a permanent storage. I think this is a basic computer science understanding. Right? This is just a computer science information. Like if we know basic system operations, we know how cache thing works, how file thing works, how cache thing works, how file things works. RAM hence is a volatile because it's not a permanent storage, but hard disk is non-volatile, which means whatever you store, whatever file you create, it's permanently stored. And then whenever you want to process them, you can open that file and access them. That's what I mean when I say uh, uh, I am distributing my data in a block. Okay. So for now you have to simply divide that whole data by 128 MB. Let's see some more example. What if I have 1500 MB data? What if I have 1500 MB with audio data? Let's say this is coming from some satellite, and my total data size is 1500 MB. This is my total data size. Now if I ask you again the same question, how many block how many block will it create will it create how many block it will create. When I copy it to HDFS. Okay. Same thing. Previously, you have taken 500 MB divided by 128 MB. Here you will say 1500 MB divided by 128 MB. And then you can use your calculator. So I'll not use a calculator, I'll use a simple concept. I'll say 128 MB first block, 128 MB second block, 128 MB third block, 128 MB fourth block. If I multiply 128 into 4, I know this is a 512 MB. This is a 512 MB. And same if I write 128 MB again, 128 MB 4 times. This is total 1 GB. This is total 1 GB. I'll open a calculator and write this. 1500 divided by 128. 11.7187. So 11 absolute block I will get. 11 full block I will get of 128 MB and 0.71. So can we multiply 11 into 128? This is equal to 1408, right? So I will have 11 different times. 8 is already I have written. Let me write 3 more times. 128 MB, 128 MB, and 128 MB. This is total 11 times. And if I add this whole value, what I'm getting? 1408. 1408. And last pending block is how much? 1500 MB minus 1408 is giving you total 92 MB. So in order to say, when I copy my question was simple, how many block? How many block? I will say it will give me 12 different blocks. 11 fully occupied, and last one is a partially occupied. So we'll see how this partially occupied can affect my Hadoop running cluster. Any question point here? So this is still today. We have seen only two features of HDFS. First one is a write once read multiple, which we know why this concept is there. And block size is by default 128 MB. So whatever data you see, you simply divide that by number until the number of block. And why we are doing this blocking, this part we'll cover tomorrow when we see what is a distributed concept. What is the concept of distributed system? So we have not yet moved into this topic, which is mainly talking about distribution.